Hello, Caymans, Mr. Eicher here, coming at you with a review, Chapter Q, Section 0 through 5. Wanted to take time to pause mid-chapter and review some things. We're going to be doing questions number 1, 3, 6, 7, 8, 10, and 12 in this video, or it might be 2 videos depending how long it gets. And the other questions we'll do in class together. So let's get started. Question number 1, the population of mosquitoes in millions in Brackenfels Park starting June 1st is modeled by this quadratic equation right there, where x is months. Find the vertex and use a table of values to graph the equation. Label axes. Well, let's label the axes first. We have x is months, so x is months. And we have the population of mosquitoes. So our y-axis is population of mosquitoes. And that's in millions of mosquitoes. There's lots of them out there. To find the vertex, to find the x-coordinate of the vertex, we can use our formula, x equals negative b over 2a, where the b value is 8, so negative 8, and the a value is negative 2. So 2 times negative 2. This would be negative 8 over negative 4, which is 2. So our x-coordinate of our vertex is at 2. To find our y-coordinate of our vertex, we would be plugging in 2 into our function. So we would be evaluating the function f of 2 would be negative 2 times the x-coordinate times the x-coordinate. So this 2 here, we're going to plug in here, and that would give us negative 8 plus 16 plus 3, which looks like it's 11. So our vertex is at 2, 11, and we can graph that here, 2, 11. And if we make a table of values to find a couple more points, we know that the y-intercept is at 3, so we can graph that point, 0, 3. Based on symmetry, here's the axis of symmetry. Based on symmetry, there's another point that's 2 units away. That would be right here. So really in my table, I already have the point 2, 11. So I'm going to pick one less on the x and one more on the x and plug that in and see what we get. Plugging 1 in, we'd have negative 2 times 1 squared plus 8 times 1 plus 3. That looks like it would be negative 2 plus 8 plus 3. So that would be a 6 plus 3, so 9. And based on symmetry, you'll have the exact same y-coordinate for the 3 in our table. So that would be 1, 9 and 3, 9. So here's our nice looking parabola that we can use to answer some questions. There we go. That parabola models the number of mosquitoes in millions after X months. So after how many months is the population of mosquitoes at a maximum? Well, the maximum is right there. So we would say the maximum is at X equals 2 months. And how many millions of mosquitoes are there? That would be 11 million mosquitoes. Sounds like a lot. How many mosquitoes were there on June 1st? June 1st is when our quadratic function started. So that would be this value, June 1st, June 1. So that would be 3 million. That's the same as the y-intercept, y-int. And then approximately after how many months will the population be 0? It says approximately, so I guess that is going to allow me to estimate. It looks like it's about 4.2. We'll say about 4.2 months. So 4 months and a week about. The population hits 0. So about 4 months after June, that's about October. So weather's getting colder. Unless you live in Southern California, it gets hotter in October. But that would be question number 1. Let's move on to question number 3. Question number 3 is right down here. Solve by completing the square. So the formula that's really handy when you complete the square is b over 2 squared. Make sure our setup, we have a value, a b value, and a c value set equal to 0, so that looks good. Notice that your a value is 2. This formula here only works if your a value is 1. So what we should begin by doing is divide everything by 2 to get rid of that 2. So that gives us x squared plus 6x plus 7 over 2 equals 0. And when we complete the square, I like to move the constant to the right side to make a little space. So what I mean is this. I like to write it as x squared plus 6x plus blank. Subtract 7 over 2. And then plus blank. Make sure you put the plus blank on both sides. And the blank is going to be the value we get when we use this completing the square formula. So our b value is 6, so we have 6 over 2 squared. That would be 3 squared, so 9 is the amount that we're going to be adding to both sides. And then we can factor the left side. X squared plus 6x plus 9 is a perfect square trinomial. That's why we chose to complete the square to make it a perfect square trinomial. So we can write it as x plus 3 times x plus 3. And that equals negative 7 over 2 plus, to be able to add these, we need a denominator of 2. We had a 9 there. If we want a denominator of 2, we multiply the top and bottom by 2. So we get x plus 3 squared. We have two identical factors equals negative 7 plus 18 over 2, which would be 11 over 2. So we get x plus 3 squared equals 11 over 2. And then we're going to square root both sides. Bring that over here. When you square root both sides, you get x plus 3 equals plus or minus square root of 11 over the square root of 2. And we can subtract 3, so we get negative 3 plus or minus square root of 11 over square root 2. That's a pretty good answer. However, we shouldn't have a square root in the denominator like this, square root of 2. So we do what's called rationalize the denominator. We make it a rational number. Rationalize the denominator over there. So to rationalize, we're going to multiply the top and bottom by that root in the bottom. So it looks like our final answer we'd get is negative 3 plus or minus the square root of 22, 11 times 2, over the square root of 4. Multiplying those, square root 4, well, that's a 2. So here is our final answer by using the method of completing the square. We have another example here on number 4, but we'll do that in class together. Next, we'll look at number 6. We'll do some factoring. Look for a greatest common factor, difference of squares, perfect square trinomials, factor by grouping, etc. So let's look at number 1. We'd like to factor this. Now you could probably guess and check, but let me walk you through the process again. We multiply the a and the c term. That would give us 8. And we want factors of 8 that will add to 9. So factors of 8 is 1 times 8, 2 times 4. So the one we're looking for, we'd be using the 1 and the 8. So to do factor by grouping, we rewrite 2y squared. This middle term, we're going to split into a 1 and an 8. So we have plus 1y plus 8y, and then bring down the 4. 4 goes right there, 2y squared goes right there. And then we factor by grouping. So the first two terms have a y in common. Take a y out. And the next two terms have a 4 in common, so take a 4 out. And you know you've done this process correctly if you get identical binomials there. So basically we're going to factor out those identical binomials and the stuff on the outside, the y and the 4. We're going to be in its own set of parentheses. And we have a 2y plus 1. This is not an equation, so this is actually the final answer. It's not set equal to 0, so we don't have to do anything. So like, don't solve from there. Don't solve for x. We just wanted to make sure you know how to factor it. Next, I'll jump down to number 4, factoring number 4. First thing I notice is we could do a greatest common factor. Both terms have a 4, so if we factor a 4 out, we'd get x squared minus 100. The next thing I realize is this looks like a difference, right? It's a minus sign. Difference of 2 squares. You can square root x squared, and you can square root 100. So if that's the case, we would factor this as x times x is x squared. 10 times 10 is 100. And since it's a difference, one of those 10s has to be negative, and one of the 10s has to be positive. And that is our final answer. Again, it's not an equation, so there's no need to solve here. Don't solve. It's not an equation. But that was number 4. We will look at number 7, 8, 10, and 12 in the next video. Thanks for watching. Feel free to give me a thumbs up. You can even subscribe if you want. See you next time.